Hey everybody, this is Larry. This is me doing what's it, three? Week 3 of the Leetcode Premium Challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's poem. I'm going to sneeze. Give me a second. Oh man, I'm like in between sneezing, so give me a second. Fast forward a little bit. Alright, maybe not. Maybe I lied. I don't need to sneeze. I don't know, but like now I'm in between. Anyway, this week's poem is 490. The maze seems like it's just a maze poem, which we'll see if it's usually is at this level is breadth search or dice draw, but we'll see. There's a board maze of empty spaces and walls as one. The ball can go through empty spaces, going up, down, left, or right, but it won't start. I feel like I've done this before, but maybe it's just another one. But yeah. So for this one, there are a couple of things you can do. Hit a wall. So, is that possible? Okay, yeah. You could pass through without stopping. That's what I was wondering. There are two things you can do. Like I said, there's BFS, or you could do dice draw. And it's just about being careful about your simulation. I think one thing that you have to be careful about is making sure that you don't do anything expensive by accident, right? Like I think one thing that I don't know how to construct this exactly per se, but you can imagine there's a case where there's the ball is here, there's a long corridor, and the goal is here, and then you just go from left all the way to the right, right? And then you simulate it, but then you also simulate it for here, 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 and then somehow it gets to n square. I don't that this is not exactly that case because you cannot stop, but in theory that is something that I would think about, right? But yeah, for this you can also use breadth search because you can just use there are two ways to write breadth search, I guess. One is by cells where you can use this 0, 1 BFSQ, or you can do some pre-calculation with respect to where the ball goes and then do a BFS on that graph, right? So almost like a dual on the current graph. It's just that when you do that, like I said, you have to be careful that you don't you just have to be careful about it, and I think in that world it's possible that there are more edge cases as a result, so it's a little scary, but not impossible, I guess is my point. All right, well, it's R and C. After considering the 100 square, which is like 10,000, so the extra is going to be good enough dice. Yeah, so let's do it. Yeah. Let's see, what am I doing? I guess we have to find the ball first. No, the ball, they tell you what the ball is and the destination. Okay, fine. I like my own variables. So start and end is what I call it. But yeah. So then we can do something like yeah. Let's just do dice draw. I don't know. And then we could do hit Q, hit push. 0 is the distance, and the direction would be also 0 for no direction. Maybe -1 for direction. I don't know. Because the idea that I wanted to do is that I keep the direction in the state so that if it's moving, yeah, it has to keep moving. So we do it one cell at a time. Otherwise, Yeah, otherwise you might kind of redo that math. Because you can think about a way in which, I don't know, you could do like a step ladder and then kind of keep on going. And then that would make it n squared if you're not careful. So though n squared, even in this case, is 100 squared. I don't know. But yeah. But with step directions, it doesn't really matter. The order doesn't really matter is what I want to say. Obviously, we need something like this. And then yeah, because I want a thing that just has no direction, so maybe just -1 is fine. Oops. Let's see. So distance, xy, and direction. Let's go to this. I guess that's fine. Just do that. And we want to set up the thing for the distance. Right. And now all we have to do is dice stream our way out. But first we should check that if distance of xy, and we have to set this a little bit. And I forgot a dimension, so I guess using 4 makes more sense then. This is greater than this. Oh, wait, what? Whatever, just if this is greater than distance, if the other way around, then we continue. If xy is equal to the end destination, then we could also return the d, which is the distance. Would be helpful if we spell this correctly. And yeah. We actually want to enumerate. Oh wait, I don't. This is only if d is equal to 4, right? Because otherwise you can't change direction. Being very sloppy here. Okay, so yeah. If it's equal to 4, we get a new direction. So then now, if distance of nx and y and no, new d is greater than d plus 1. Yeah, it's +1 because now we're setting a new direction. Then yeah, then let's put it in. Okay, and then we have to put on a heap. D plus 1, new d, right? Alright. Otherwise we just keep going forward. So dx dy is equal to directions of d, right? And I guess we do the same thing. A little bit copy and paste, but I don't know. I don't know how I feel about it. And of course you can combine these if statements, but yeah, okay, fine, let's do it then. In this case though, it's not d plus 1 because you don't add 1 if you just keep going straight. So yeah. Did I mix D again? This is not D. This is no, this is D. But this is distance. Okay. Wow, I mixed. Naming stuff is hard, and when you misname stuff, this happens. So be careful. Okay. Yeah, and then this is distance because we don't update the distance. We don't need to. And then we push on the heap. Though this is like put it on the next thing. Oops. Right. Oh, and we have to. I actually lied because I forgot to check for the walls. I always forget to check for the walls. I mean, it's a easy add, but I just forget to do it sometimes. So it's 1, right? So maze of nx and y is equal to 0. Otherwise, we don't go. And also this as well. Well, no, this one I needed to do an if statement here, I think. That's why I separated it, but I forgot. The reason is because now then we can do else, because if these constraints don't hold, then we have to stay where we are, and then we choose a new direction, right? So that means that else if distance of x, y, and then now we have 4 is greater than distance, then now oops, I keep on doing that, and then 4, right? And that's pretty much it. Otherwise, I just realized this is a Boolean question, so I kind of overdid it a little bit with the distance. So we don't even need to return the distance. This actually makes it a lot easier because then now we really should have done BFS then, but I wasn't paying attention. I just kind of missed it, to be honest. I don't know why. I mean, I just missed it in my head. I mean, I don't know. Oh man, did I? That's why. That's the other thing. Oh no, the other places I did okay. Just that place. I always forget about this because it is a very awkward use of like there should be a first class heap object, but that's what it is. Oh, I can't do this. This has to be. I didn't know that I had to think about it, but then I just forgot as I was doing it. All right, there you go. But as you can see, easy fix. But as long as you have the right kind of internal modeling for a problem. But I forget it's true false, otherwise I may have done it the other way. Anyway, let's give it a submit. Alright. Well, I just kind of, I don't know. That's why my time is a little bit slower, but that's fine. Yeah. What is the complexity here, right? Well, I mean, you know, this is just standard Dijkstra, so it's going to have standard Dijkstra complexity, which is what is it, y log v, or well, technically y log y the way that we're doing it, but you know the y gets. Oh no, I think I said y because I'm confused, but actually the number of nodes is actually r times c, which is the size of the grid, which is quadratic in that way, but it's not quadratic in the size of the input. It is going to be v log y still, or v log v, depending on how you want to define y, because y well, in this case, y only has only up to 4 edges for each node. So, you know, up, down, left, right, and maybe new directions of 5 edges. So y in this case is going to be another v. Even if y is v squared, you know, the log takes care of it. But for each node, for each vertex in the original graph, there's at most 5 nodes in the new graph, and therefore it's going to be v log y because we process that, you know. This loops once or 5 times at most for each original node, and each of them does, you know, at most 5 what happened here, 5 heap operations, which is you know, log e yeah, but or log v in this case, perhaps, depending on how you want to say it. But yeah, that's all I have for this one. Let me know what you think. This is just standard dice straddle. I took a while typing it out and making silly mistakes, but in concept, it's not so bad. Yeah, let me know what you think. I didn't end up sneezing, so I don't know. But yeah, let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the week. I'll see y'all later and take care. Bye bye.